Alright, so as described before, my phone overheated. And so what I did is I figured out a way to connect multiple components, peripherals, to my ridiculously expensive DJI wireless mic, which didn't want to work in itself. But now I'm recording on the new phone, just because I rigged some stuff together. So now I'm back in business. I hear an echo. It's probably because I have my headset on. I'm maybe hearing myself. I don't know. All right, so what's my plan here? My plan. So I think what's really holding this in, because it's moving. I think the filament in there is holding it in there. I'm not entirely sure. I really don't want to just pry on it in case there's more holding it back. I don't want to break it. I guess I just need to take some screws out. 2 more screws. Hopefully they're not too hard to get back in. It's probably too small size. Nope, that's the one. Not a lot of travel on this. So I wonder if I have a time limit on this phone. I'm begging not. Please don't have a time limit on this phone. Let's see what happens if I don't know. Not yet. Are we on camera here? So I don't see a time limit. So hopefully it just lets me go. Record as long as I want, which would seem reasonable. Unlike my Galaxy Note 9. It does not allow that. Alright, so I took those 2 screws out and nothing happened. Great. It does seem... Oh, sweet. Alright, let's unplug that. Connector. There we go. Yeah. I can unplug that. PCB. You can see here where the connector broke. So that just kind of falls out. It's the heater connector. It just kind of falls out, but I was able to wedge it. I was able to kind of stuff the wires in behind the something, whichever part I stuffed it in behind. And it allowed it to hold itself in there. So fair enough. And they were going to send me, they said they were going to send me a new heater nozzle and a new PCB. And the heater nozzle showed up yesterday and no PCB assembly. So I don't know if they changed their mind on that or for some weird reason that would be a separate shipment. So I guess I should contact them. I wasn't too worried about it, but now I'm a little worried about it. I would like to get that. Alright, so yeah, we have some filament in there above, at the heatsink. Yeah, Teflon tubes, that's interesting. It's insulating the screws. So the screws to insulate thermally, so the screws don't put heat into the heatsink, or so the screws put less heat into the heatsink. I hear my dog barking, wants to go in the house, and it's like 700 degrees out there. Somebody will let him in. I'm going to pause this and I'll be right back. Alright, I'm back. So, where we left off was I got the heater nozzle, and I believe I loosened that set screw. That would be funny if I actually just didn't loosen that set screw. It's tough to know from on camera here. Is it the right size? Yeah, that's turning the set screw. That is, oops, I don't want to turn too much. So I can't really turn it, which is kind of not a good sign. And I'm sure I cooked the hell out of that PLA. Don't run PLA at 260. And I knew better when I started doing this. I knew I shouldn't do it. I had flashbacks to many years ago, my first 3D printer, when I clogged the nozzle by cooking PLA in it on accident. And I sort of somehow forgot I was thinking about that, and then I just went ahead and clogged it anyways. So, I need to get that. I can see the filament was blue, so I can see some filament there. And what's going on? It goes right up into here. That's not good. I can see the melted filament in there. Am I still looking at that? Over there. Yeah, I can see a little bit of blue still here. But maybe I can push that out now that I got this off of there. This is not my smartest move. Not extremely happy with myself right now. Let's release the clutch there. I should probably just try to push it down. And see if this guy will fit in there. Okay, looks like I'm going to take out the extruder also. Alright, so ultimately, I'm pretty sure that one way or another I can like hold this in a vise and press that out. Maybe even with the vise and a pin and press that out. So I'm less worried about that. So I'm going to go to here. I'll take the extruder out. If I use the right size tool. Why do is it this guy? There we go. I believe this is 3 screws for the extruder, 2 on this side, 1 on the other side. This is a bigger project than I was thinking it might be. Entirely not what I planned on doing today. I was going to watch this print all day and work on actual projects that pay the bills. But that's all right. Actually thinking about maybe doing some print farm type stuff once I get my other one up and running. What happened? Okay. Stuff still stuck. Let's unplug. Oh, this thing is a pain. This wire retainer. It's cumbersome. It's just a little plastic tab. You can't see it from there, but it's kind of the wires just kind of tucked behind it, and it's kind of abusive on the wires, trying to manipulate them. I kind of don't like it. Although, okay, if I do them all one at a time, it's actually not bad. Okay, there we go. One extruder and motor. So when they send you a new extruder, they don't send you a new motor. Just a little tidbit there. And so that is out. I need to pull. So if you can, let me tilt this thing again so you can see. Bowden tube and blue filament. So it's I believe it's a blue Bowden tube and blue filament. So I'm going to try to just leave that out or push it through. I'm not sure at the moment which would be a smarter way to do it. I mean, maybe, I bet you, actually, I wonder if I do want to heat that, because I'm sure it melted and expanded and then hardened. And so maybe I want to heat it up. But maybe it'll just push through. So, well, if I push it, that's going to I'm going to call it the Poisson effect. I know the Poisson ratio is like if you stretch an elastic and it gets narrower as you stretch it. That's basically the Poisson ratio. So, what am I on here? I'm trying to break stuff here. I got stuff under my printer. That's not where that goes. Okay. So I think if I push on it, that may be worse. I think if I pull on it, that's probably better. And there's also the Teflon Bowden tube. Technically, that's, I mean, everybody calls that a Bowden tube, but that piece of Teflon tube is the same material as the Bowden Teflon tubes tend to be, but I don't think that actually acts technically as a Bowden tube. I don't know, maybe. I guess it's debatable. Anyway, not entirely relevant. I think I'm going to try to push it through. I need some pliers. There's some mini vice grips right here. Might do the trick. Please do the trick. Oh, it moved. It moved. Yes, so I pushed it down. Yeah, we might be back in business pretty soon here. So if you can see, this phone's supposed to have a crazy zoom on it. One of the reasons I bought it. If only I had a headphone jack, I'd be happier. So you know what? That's not focusing. There we go. What? Like I think it. That's some crazy detailed zoom, eh? But you can see it made like a plug. Interesting. I wonder if that's a symptom of. It seems like it shouldn't do that. It seems like the Bowden tube, even though I just told you it might not be called really a Bowden tube, but I guess it probably is. There shouldn't be. It's like a nail head. So that tells me that there may be a gap. I guess that shouldn't really matter as long as that little gap shouldn't matter as long as the hot end stays, as long as the cold end stays cold enough. But if you have PLA at 260, then that'll do it. So I'm not going to blame the gap. I'm going to blame the stupid operator for running PLA at 260. But I could have sworn that was ASA. Anyway, the nail head came off. Let's grab it and turn it a little bit. He's still on there. He's back out here. So, how to fix your... I guess I need to lean it back to be visible here. How to unscrew yourself after you screw yourself. Right? Because it's 3D printing. I'm sure most of us do dumb stuff like this once in a while. That didn't want to come out. I guess I just have to push it through from the inside as I was initially. So I'm going to just try to push that back in there. And I guess I'll just use these same. Oh, you know what? I think I need to pull the Bowden tube out first. How's that going to work out? That shouldn't be stuck because that's probably silicone. It should not be melted. I'm damaging that. No. Alright, I guess I'm just going to keep pushing that through. Leave the Bowden tube there. I just deformed it a little bit. Not necessarily good. Just threw my tool on the ground. And let's try to push that through. I'm sure I lost my view. Let's push this guy through. And please feel free to fast forward through anything that you're not interested in. That is pretty jammed. That'll help. Put it up. I'll put the rail up against the or the print head anyway, up against the body there. I can't really push this through with the vice grips because I can't push the Bowden tube through. Yes, I'm calling it a Bowden tube from now on. I don't care about semantics. Go, go, go. Go, go. I'm pushing. Wow, I don't know how that didn't slip off, but it didn't push it through. I guess I could grab the tool with the vice grips. That's amazing that that didn't slip off. I mean, maybe I can pull it out. I'm afraid I'll just break it off, though. I have to be careful about this because I don't want to get myself into more trouble than I'm already in. I'm almost tempted to drill it out, but then I'll totally destroy a bunch of stuff and probably drill too far. And so let's do this. Let's grab this tool with the vice grips and push that way. Tool and the vice grips. Yeah, you're probably off camera for the moment. Apologize. This is sketchy. Yeah, that's slipping off. I mean, I could hit the whole thing with the heat gun, but that's not going to do it. That's not going to do it. For a second there, I thought I was good until the head of the nail thingy broke off, and then that just broke right off. I wonder if I can get the center started with this old tetanus tool. Definitely don't want to stab myself with this rusty old thing. Okay. I made myself a dimple. I can't really... I just put a hole in the middle of it. Almost like I didn't. Let me think. How can I get that out of there? I mean, I already pulled on it and it just broke. I pulled on it from the other end and it just broke. I push on it from either end and nothing good happens. You see the... Oh, is that actually the tube? Oh, the Bowden does slip all the way through. Okay. Maybe I can just push the whole Bowden through. Let's see. Let's try it. Because I can see the whole end of the Bowden tube from the bottom. Alright, that's what I gotta do. Grab the Bowden tube and push. Even better. Instead of grabbing it, grab the little bit of PLA that's left above it and then push the Bowden tube. Go! Now I command you. It just bent over. Not ideal. Well, at least I can see the Bowden tube at both ends, so I have a feeling I'm just going to end up drilling both out. Not what I want to do, but I'm just going to screw it, grab the Bowden and pull with a little wiggle. Bam! Nailed it! Yep. Look at that. It's a little confusing because it's a blue filament in a blue Bowden tube. Bowden tube destroyed. Might still be reusable for what its purpose is. Let's This plastic is stuck in there good though. So we can push that out with this hexagonal tool. Where is it? Try to push that out. Huh, who knew this? This Teflon stuff's pretty slippery. Who knew? Get out of there. Now this I might heat with the heat gun. How can I? So what I have going on here is the plastic is recessed in there some, so I may be able to, now it's going to act sort of as a guide. So if I can put this up against a hole that is somewhere, there's a hole in my vice grips, dear Eliza. So I can use that, potentially. Nice, look at that. I might have to take that spring out of there, which will be annoying. What I'm doing. So I have a hole in the vice grips to support the Bowden tube, and it's reset. The filament's recessed in there a little bit, so this might actually work because I can't hold the tube. It's so slippery. So if I back it up against that hole there, I'm not even sure if I can end up. Ow! That didn't seem to work. Do I have any more of this good Bowden tube around? I thought I had some somewhere. I know I have a new pack of the white stuff. I have a feeling this stuff is higher temperature. Not entirely sure of that. But the reason I think so is that this is a different size now. It should be the same size, I think. Is that they use white for the rest of it and then they use blue for inside. So that makes me think the blue is probably higher temperature, or at least this blue is higher temperature. So I don't necessarily want to switch to a lower temperature tube. Ooh. I was going to say I could sacrifice from my Ender 3 S1 Pro, have a spare hot end assembly for that, but it's actually I bought the lower temperature one because I thought it would work better with PLA, because I was getting very similar jams actually with PLA in my S1 Pro, and I figured it was because it was all metal hot end, and including the gears, and it was just transferring all the heat into the PLA, and it would just get soft and clog. And so, how can I get this? I think I'm going to put this in my vise outside, and I'll be right back. Alright, so if I had to characterize myself right now in 4 words, it would be sometimes dumb, but sometimes resourceful. And so it took me about a second and a half out the door to realize I can't hold this in a vise, just crush it, and it'll be useless. But what I can do is take a socket. I happen to have just the size that works really well, and it's like a reverse Torx. I don't know if I've ever used that. I bought it for like the starter on my BMW motorcycle or something. It was like one thing I ever bought that had like a reverse Torx head on it, and so I bought this set for that, and I think I didn't even use it. But it's always good to have stuff around. And that was like butter, I say. And that thing popped right out like a I don't know, you can make up your own funny thing, because anything I have a few different things I was going to say there was all offensive. So anyway, so this is a little wallered out, but I think it'll still work. If I put the wallered end down, I think that'll still work. So we're halfway there. So I still have to get this guy out of here, because I still have to, no matter what I want to do, I have to reuse the seatsink, and so I need to get this out of there. But this doesn't even twist. Like, there's nothing that's supposed to be keeping this from twisting, and it can't twist. And that I can see, like it's like crystally. Like I totally cooked that PLA in there. I wonder if I can get it started with this thing. Get some of the material out. That's pretty useless. I mean, like I say, so I could try to force it and turn it, but the whole point of a heat break is that's a super thin wall. And so I would really put the brake in heat break if I did that, I believe. And same thing, I thought about prying it, but I think the same thing would happen. Now, that said, I don't really want to sacrifice this thing, but I think it's probably already sacrificed. I could potentially heat it up with a heat gun. But, I mean, this filament is so crystallized, I don't think it'll soften again. I guess I could do a test and see if it'll soften. But look at that, it's all cooked and hard. Maybe like impact or something. I could drill it out. How far does that? I mean, actually, I could potentially push that out very similarly to how I just pushed the other thing out. Although, I should get that filament off the top. Where's my knife? I don't have my knife on me. Maybe I can use these. I have a favorite old knife that's a combination. It's got two blades. One is a little serrated. It's like two folding blades, two folding lock blades. And one is a conventional locking blade, but it's serrated, which is kind of nice. And I only use that for food because I don't want to dull it. And the other is, 'cause it's not a super expensive knife. It's one I tell you. So the other blade is a razor blade holder. So it's super convenient for everything. So I use the razor blade side of it for everything except for food. And for food, I use the serrated one. It's a really nice little setup. But it's not, I mean, you know, it was like $20 at Home Depot deal. So it's not like it's not like super sharp. I mean, it's sharp enough, and especially with the serrated, it's sharp, but it's not, I'm sure it's not like the best hardened steel, blah, blah, blah. Probably hardened, but it's not like K1 or whatever they. Interesting. K1. K1, I believe, is a steel that they like to use in knives. Correct me if I'm wrong. I'm an expert because I watch a lot of Forged and Fire, so that makes me know a lot about everything. You can actually learn some things on that show if you pay attention about material science, metallurgy, things like that, hardening and things. Although they don't go into a lot of math, it's very mathematical if you really want to be precise. Hardening. All right, so I got the sort of the head off of that, and I think if I push on that, something might happen. I almost want to. So that filament right there is still blue. I could melt that filament in theory. And if I heat this up, hell, even if I didn't heat it up, is this? I'm not sure if this fits through there. I want to get a little deeper. Get rid of a little more of this blue plastic, but I don't want to accidentally shave any of the aluminum off the heatsink either. And I don't want to stick this. I don't want to stick this thing through my hand either, because that's just the kind of thing I would do. All right, so I got some of the plastic out of there a little bit. Let's scrape some more of it out. So this is what happens when you tell yourself, don't do it, and you're like, I'm pretty sure it's ASA. Don't do it. You know, I get the one guy on my shoulder going, don't do it. You're not sure it's ASA. And the other guy on the other shoulder was like, I think I had some blue ASA, and this doesn't have a label on it, so I think it is. And I put a little flame to it, and it smelled like melted plastic. So I'm like, I'm going to say that smells like ASA. Evidently, I don't know what the hell I'm talking about. And end up in a predicament like this. Okay. Idea time. I was going to say, if I heat that up, then I can probably push it through there. But I have a soldering iron and a whole bunch of different tips. And I bet I just might have a tip. Narrow or not? I bet I don't. I bet it's not that narrow, but let's see. I got a whole thing of soldering iron tips right here. Ooh, I see a little I might have. Oh, look at that. Listen, I don't solder. And years ago I bought a soldering iron. Actually, I think it was for one of my projects. It's funny how, I mean, I already had. I like to collect tools anyway. If I see a tool that I don't have and I say, hey, I might need that someday. If it's not too expensive, I'll tend to buy it. And then, most of the time, or I don't know about all the tools, but lots of times I have decided, I have used tools that I didn't necessarily, that I rarely use, but I have, and it's basically saved my behind. So I got my soldering iron. It's actually pretty nice soldering iron. So you can see what I use it for. It's melted plastic all over it. That's pretty much what I use it for, is melting plastic. And not great for the tips maybe, but I got a whole bag of tips. And I think I soldered one thing with it. I think I actually soldered once with it. True story. I'm not even just being funny. Or allegedly, or trying to be. Whichever. Oh, yeah, that's a good idea. Plug it in before you change the tips. Good idea. Where's the... there it is. How do I change this tip? Is there a set screw? This comes off. That was already loose. How do you do that? I don't even know how to do this. I'm just gonna wing it. Looks pretty straightforward. Yeah, that worked. And I got plastic all melted to it, so it's seized in there. So I think I need to heat it up to get this plastic. Oh, I keep that one piece. Nope. Nice. Popped it right up. Popped it right out. The plastic fell off of it. Good deal. Swap the top. Look at that. We're gonna melt that bad boy right out of there. All right, let's see. And so this is a pretty nice little thermostat. I mean, what do you call it? Soldering iron. It heats up super fast. No, I don't want it to go super high, but you can dial right into your temperature. And so we're PLA, so we're why did it go to 265? Well, 204 looks good. No, why are you at 265? Oh, I see, because it heated up to 265. See, that went up to 265 that quick. That is amazing to me. And I don't want to do it at 265 because then I'll burn it in even worse than I already did. Alright, 220, that will be good. Let's melt this out of here as much as we can. I mean, I don't need to get it all out of there. I just want to get enough. And this heatsink is going to get hot and I'm going to burn myself. I just want to get as much of that out of there, or at least put a hole in it so I can potentially push it out. You can see there, I made a hole through the filament. Kind of neat. Now it looks like a Bowden tube, but it's not, it's filament. And, I mean, I wonder, I guess I could just keep pushing on it, and the heatsink is going to get warmer and warmer. And hopefully I let it go before it gets too hot. I can push on it for a while and see if it pushes out. Yeah, it's getting warm. Interestingly, I noticed this has a 3-hole flange on here, and they only use 2 screws. The funny thing is the third screw goes to the set screw. So I don't know if they're going to put it, if they wanted you to lock the set screw with another screw. That's an interesting idea. I'm not sure if that's what was going on there. But now at least I could put that, potentially put this in here and then drive it out with something. Maybe the vise. I'm going to try to push it. I'm going to go, oh, let's see, what can I put around this? I guess I could put a big socket around it, and the hole would let the wires go this way. Yeah. I'm going to do that, and I'll show you, and then I'll be back. Okay, so here's my plan. I'm afraid I'm just going to bend this hex key, Allen wrench, whatever you want to call it. But I'm going to try it. And maybe I'll find something instead of this. Like maybe a nail. Maybe a nail, but I think this point on it might break. Might actually put outward pressure, actually, and cause it to act as a brake. So that might not be a good idea. But so I have a socket that clears this flange, but seats on here, and hopefully leaves enough room for the wire to go like this. The wires. Yeah. Good fit. I'm going to put this, and then I can do, so that's my backing setup. And I can put this in here, and then put this in my vise, and squeeze it, and hopefully pushes that right out. So I'm going to go try that. I'm not going to move my camera because it's kind of a pain. Alright, so a little update. It was scary, and then pushing on that in the vise didn't work yet. I didn't push too hard. I didn't have safety glasses on, and the hex key was kind of bending, and I was like, that's going to shoot up right through my eyeball. So, and it wasn't really moving it. And so I have a new plan. I'm going to put heat to this, and hopefully I can sort of melt some of that plastic that's in there, and maybe that'll let me rotate that. But before I do that, I already pulled one out. There's 2 Teflon tubes here to keep like I was saying, to insulate so the screws don't radiate heat as much to the heatsink. And so I'm pulling those up because as far as rumor has it that it's extremely toxic fumes that comes off of Teflon if you overheat it. So because I'm gonna hit this with a torch, I don't want that to happen. And I say a torch, my griddle is right over there. Because I was gonna say, because I have a MAP gas torch, and I don't want to melt I don't want to melt the aluminum. I'm not sure if MAP gas can melt aluminum, but it's hotter flame, and I think it probably could if I overdid it. So I don't need to go that hot. Actually, I can hit that with my I'll hit it more with my thingamabob here. That's what I'll do. We'll get her back up to 220. I was at 204 before. I'm going to go 220 this one. 220. And stick that in there. Let's see if I can apply some heat so I can loosen this up. Getting warm. Definitely, these things definitely getting warm. It's starting to get hot. It's moving. It's getting hot, but it's moving. Ow, but it's moving. Ow. Okay, plan B. I'm gonna hold that with the vice grips. Yeah, I don't wanna be too reckless here. I gotta be careful I don't drop that because it's really hot. That's hot too. Alright, let's put that in there for a second. And that's not too hot. It's warm. I need to grab the other piece. Yeah. Alright, so that cooled off a little bit. I need to do this and put that through there, and then put that on my belly, and then grab that with something else so I don't burn my phalanges. Any more pliers over here? I brought my tool caddy in the house, evidently, because all my good tools are not here. I gotta have more than one pair of pliers out here. Huh? Kidding me? There's so much stuff. Ooh, haha! Little repurposing action. Little binder clip pliers. How do you like me now? So we hold that with this. We stick that in the hole. Put that against my belly, we take the binder clip, we grab the heater, and now, oh, it's almost like I'm not part stupid. It's turning. It's turning. Look at, I might save everything here. This heater nozzle may live again to see another print. Yeah. It's coming out. It's coming out. Look at that. Oh, saved. Look at that. Bam. All right, that's hot. I think I just got some good fumes, whatever that was. So, yeah, check for my obituary. While that's hot, I should kind of scrape that out. Whatever's in there. All right, that's good. I have wire stuff in my tweezers. Not sure if there's anything in here that really needs to come out. Looks like metallic surfaces, so. Oh, I'm so happy. I'm so happy I didn't break anything. Except for my paycheck. Because I'm out here instead of billing clients. There's definitely some gooey schmegma in here. Looking good though. I mean, it's in one piece. That's what I really care about. Ah, don't drop it. Jeez, eh? All right. We are officially in the putting it back together phase. And I'm not even bothered trying to clean that nozzle right now. I'm going to put the new one in there. But before I do that, we will compare the three. So I have the one that came with it, and then I have the one I replaced with this one, and then I have the new one that's going in. So, let's have a little show and tell here. Let's get this out of the way. I need to unplug it. That was my annual trip using my soldering iron, and as usual, it's just melting plastic. But it does a damn good job of it. So, let's see. Let's get the tip out of the way. There's a bag of tips. This is a funny joke about something like that. But anyway, this socket, that's going to go back in the garage. Let's put down my, well, let's put it over here for now. And so there's one nozzle. Here's the new nozzle. Where'd the original one go? I grabbed the original one a minute ago. Yeah, a metaphorical minute ago. Alright. So this was the original one. And actually, so this one, the last time I had this apart, this thing was all covered in black. And I was like, geez, it almost looks like the binder burned out of the ceramics. Oh, ceramic cracked. Ceramic's cracked. How about that? Cracked and chipped. It's cracked. There's also like a triangle of it missing. Look at that. So, but it would probably still work. So, I mean, I don't think the ceramic itself heats up. I think it's the ceramic is potted around heating wire elements. And you can see the heater wire elements in there. And it looks like, I'm hoping that it's right at the loop, but maybe not. Because if you look, I don't know if you can, if it comes through. Let's show it on the new one. So you can see, if you can see that, inside this white ceramic, I'm going to cross-eyed blurry here, trying to focus my eyes on it this close. Back up, there we go. So I can see, can you see that loop? So you have the wire connect soldered here, and then there's like lines. See those lines? Those are like a path of heater wires, and then it's encapsulated or potted into the ceramic. And so when they say ceramic heater, that's all it is. It's ceramic around. Okay, and at this end you can kind of see it's a circuit. It's a circuit within the ceramic. I don't know if that shows up on camera. Hopefully, it's very faint, but there's basically a circuit that goes off these two soldered leads, and racetracks around, zigzag, 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 comes back to the other lead inside the ceramic. And so the ceramic is just holding the wire together. The ceramic isn't the actual heating element. The wire within the ceramic is the heating element. Now, I watched a video from Nathan Does Robots. I said that once as a joke, and now I think that's his name. Nathan the Robot Lover. What is it? Nathan builds robots. Makes robots. Nathan builds robots. Anyway, cool dude. Does some cool stuff out there. Definitely, I like watching his stuff. Very informative. And I'm like twice his age, but I still learn stuff from him. It's good stuff. So he was saying something about the variable resistance of these things, and it made it sound like to me that he was saying that the ceramic causes the variable resistance, but that doesn't make any sense to me. I think it's got to be the wire material. Something about thermal runaway. If it gets too hot, like the hotter it gets, the higher the resistance goes, and therefore it lowers the current. It doesn't lower the current, but it decreases the rate of increase of current with the or power. Yeah, for the same given current, you get less power because the resistance is higher. Something like that. You can tell I'm not an electrical engineer. I barely speak electrical, but I kind of get it. But anyway, so that's the deal there. I've definitely dealt with heaters and stuff, with high temp heaters, like I was saying before, spacecraft components, things like that. Have all kinds of cool stuff to learn. Oh, you know what I want to do is make sure this heat break and nozzle are touching, because on actually though, is that really the case? Because I thought I was getting leakage of filament at the top of where the nozzle meets the heat break. Yeah, there's plastic residue up here. Wait a minute, which one is this? Okay, this is the second one. So let's get back to comparing the three. So this was the original. I'm going to put all three in my hand here. And this guy had this guy. And this guy had this guy. And this guy has this guy. Alright, so that's the insulating socks. Right, so this sock got totally destroyed. Not a big surprise. It was already half destroyed before I even tried to remove it. This sock I really salvaged today. Pretty happy about that. And this is the new one, which I'll put on. And so let's see. So you can see here, let's flip this over so I can see the Kapton tape better. So this orangey tape, that's Kapton tape. It's really high temperature tape. Like I say, they use that on spacecraft. If you need to tape something down, that's basically what they always use. I say always, so it's going to be wrong. But in my experience, that's what they always use. And I see it every time I see like a video of them building a satellite or something that's Kapton tape all over. You watch for this clear orange tape. And like I say, so they have a different adhesive for spacecraft. This is probably a cheaper adhesive. I don't remember. It's like one of them is the acrylic adhesive and one of them is the silicone adhesive or something. I don't know. But anyway, two different adhesives. So, and that's the heater wires, the two heater wires and the two thermistor wires on all of them. And so the thermistor wires, so let's start with this one. So this one is the sleeved. It's got this, looks like stainless steel to me, sleeve around the thermistor, like a shell to protect the thermistor. And then it's got these, anyway, I was just thinking, maybe I was thinking about it backwards. They all seem to be brass at the bottom, and whatever this black is at the top. But so this has the thermistor in a protective sheath. That's the correct word, sheath. And this does not have a sheath. And this does not have a sheath. Of course, this is covered in gunk. I'm going to try to break that off real quick. So these guys. Can I actually use this still? I bet technically I could actually use this still. Why did I change it? Was it? Whoa! I almost just cut the wire. That'd have been bad. Well, that wouldn't have been horrible because I got three of them. They actually sent me an extra extruder too. They sent me 2 spare extruders, and then they even said the other day, "Well, do you want blah blah blah, or do you want another extruder?" And I was like, I'm thinking, I already got 3. I already got 2. Well, not 2 spares because the first extruder was junk. Bad design. You know, it was great at first, but it wore out. So I got some of that off. So anyway, I guess that's enough for that. Let's do this again. Yeah, I think I could actually reuse that heater. Why did I? I'm trying to think what was wrong with it. Why I got a new heater nozzle. I didn't remember. Oh, that'll come to me. Oh, because I got a heating error. But in retrospect, I think the heating error might have been the bed. I mean, I told them the code, and they said, "Okay, we're sending you a new heater." I said, "Okay," I took their word for it. But it didn't. As far as I'm concerned, I have no way of knowing if that code was for the bed or for the heater nozzle. So I think that heater nozzle might actually still be good. I'm going to keep it. So this thermistor has a sheath. This thermistor does not have a sheath, and this thermistor does not have a sheath. And they all have braided wire on the heater. I'm not sure what this. I guess that's just shrink tubing. This white stuff, I think that's just shrink tubing to hold the 2 wires together so they don't flop all over the place. So they sort of self-support each other. And then you have the bare. It almost looks like they're actually using like a speaker wire for the speaker wire, magnet wire. It looks like magnet wire to me for the. Which kind of doesn't make sense because that stuff's not super high temperature, so I'm not sure what the deal is with that. It's got some kind of almost like an enamel. Excuse me. I think that means I need to eat lunch. Anyway, we're almost done here. I think maybe sort of. We'll be done like by tomorrow. So you can see the Kapton tape here, holding the 4 wires together. A little short length of Kapton tape, and on the second one they had a longer length of Kapton tape. That's one thing that jumped out at me. But other than that, they look identical. Other than this one's correct, but maybe they did something a little different. Other than that, I'm not sure. For the most part, they look the same. But yeah, so this one they don't even have Kapton tape on there. So that's a little bit strange to me that they didn't put the Kapton tape on the new one. But that's probably a pain to install and then quality control. It actually almost looks like a sleeve. Now I can see overlap. That is a tape. They're wrapping that manually. I assume manually. I don't think a machine. Well, maybe a machine would do that. Maybe they have a machine doing that. I don't know. But if you don't put that on there, it's less work, less cost. So if it works without it, great. And evidently it works without it. Otherwise, they look basically the same. Same 3-hole flange still, and only using 2 of them. That's kind of funny to me. I think they did a couple things. I was wondering on that gap on the door over the display housing if they're kicking themselves after, like, oh, we made the display housing slope up, so now the door has to have a bigger cutout to clear it. I was thinking about that the other day, if it was just one of those design mistakes, and then you ordered a bunch of parts, and then you're like, okay, well, let's put a hole in the door so it clears the thing. I don't know, maybe they did it on purpose, maybe they did it on accident. I don't see any benefit of doing it on purpose, but, well, maybe there was a little because it angles up. I don't know. Who knows what those crazy design engineers are thinking, says the crazy design engineer. Okay, let's put it back together. Happy time. Alright, this shouldn't actually take very long. Somewhere on here I have boron nitride paste to put on the heater. Alright, so where are we? This guy, let's trying to think what order I need to do these. Oh, I know what I wanted to do. I wanted to make sure that the nozzle is seated against the heat break. And it seems to be, I say that because I can stick my fingernail up in here, up under the head of this. Right? I can fit my fingernail up under the head of that. And let me grab a nozzle that's not installed and make sure there's not a shoulder on it. I don't want to really loosen that one if it's right. Oh, okay, that's interesting. They have a set screw holding the thermistor, and not a big deal. I mean, not a big surprise. That's good. Where's my nozzles? I just had them. There it is. If I grab a nozzle that's not installed, just to confirm that none of these have a shoulder on them, and I believe they don't. Yeah, so there's no shoulder on this. So if I can fit my fingernail above the hex like this on this, that tells me that it must be seated to the heat break. And it's kind of tight, but there's definitely a gap there. So I'm sure they installed the heat break and then tightened the nozzle up against the heat break. I'm tempted to tighten a little extra, but I don't want to. I'm going to trust them. People need to more often not think they're smarter than the design engineers, because sometimes the design engineer knows something that the layman doesn't. And you say, just going to put more torque on it. Put a stronger screw in it. Yeah, well, good way to strip out your hole or other things, or deform the faces and cause problems. So I'm going to, based on that little gap there, I'm going to trust that they have it to the right depth of the heat break into the heater. And I'm going to trust that they're using a torque wrench to... Oh, there is a little step on this end. I was wondering about that when I was looking at it. But once it's melted plastic on it, it's tough to tell. But there is a little bit of a step on this end. Totally separate thing. All right, so I trust them. I'm going to trust them on that. I'm going to put these nozzles back. And my giant box. Think I got enough nozzles? And the funny thing is, I bought a CHT nozzle for this printer, and I lost it before I installed it. How do I lose a nozzle? I don't know. It's a bigger nozzle too. I don't know how I lost it. Take a drink. Okay, let's get to business. So this is going to go in here, like so. Let's see how it fits. Oh, it goes in like butter. Alright, we didn't damage it. Or at least we didn't damage this. Or at least that hole. Plenty of other things I might have damaged. But I need to put boron nitride paste in there. And you know what I'm going to do is because I don't want to get boron nitride paste on the end. Actually, maybe I do. Maybe that wouldn't be super bad if I did get a little bit on there. But if I get paste in it, that might cause any minor problems. So I'll probably stick to my original plan. I'll put it in a hair, and then I'll put a little bit of boron nitride paste on there, and then I'll slide it in. And you never want to get boron nitride paste on the narrow part. Is that taller heat break? I think the heat break is a little taller now. Look at that. I don't think I saw anybody notice that before. Look at that. Unless that's just in farther. Could be just... Yeah, it's just in farther, because this one... Which one is which? This is the original one. Yeah, I think this heat break just went in farther. Is there bigger... This is all melted plastic. I can't tell if that's... Looks like a bigger gap here, too. So I think this heat break is just screwed in farther into the heater. I think that's all that is. I think it's... Although it is a bimetal heat break, so look at that. That is different. So... It's hard to... These actually look like they're reversed color-wise. I'm not sure what I'm getting at. So you can see the portion that interfaces with the heat sink appears to be copper colored, but the narrow part is like silvery colored. So probably like I don't know, nickel plated steel or something. I don't think it would be. I think you need nickel plating to stop the corrosion. Like they say, stainless steel doesn't rust. It does. It's just a lot less, and it probably doesn't rust through. But you can get surface rust on most stainless steels. And so, I say most stainless steels, on common stainless steels. People know about 316, 304, 188, 300 series, whatever you want. All those are all very related. I'm not sure about like 17.4 pH and things like that. And there's so many. There's like, I remember seeing a chart, like a flow chart of all the different types of families of stainless steels. There must have been 50 on that sheet. And it was a super old. It looked like it was mimeographed and then photocopied. It was like so old. So they've had stuff around for a long time. I mean, lots of stainless steel for a long time. Anyway, so that is a bimetallic heat break. This actually looks like two different colors, but the top is like silvery. But that could just be boron nitride or something. Boron nitride is white though. But the inside looks like brassy. But that could just be plastic on it or something. Because there's a whole bunch of schmegma. Because this one does look like it was leaking plastic up over the top. Like this nozzle might not have been in all the way, but that had to be because that heat break was way in. And this one looks to be all the same color. So this one looks to be all, I don't know if that's nickel plated. So I think the nickel plating would definitely help to, because nickel plating, nickel I believe does not to generally. So I think it's, I was about to say that I think the nickel is a big part of what makes stainless steel not corrode, but maybe it's more about the additional chromium. But I think they're also nickel, but there's also high nickel alloys, which are very corrosion resistant, used a lot in military stuff, like shipboard stuff, like seagoing stuff. Use a lot of Inconel and similar high nickel alloys. Very strong, very corrosion resistant. So I'm guessing they're nickel plated. Nickel plated, who knows what? Nickel plated copper? I don't know. Probably nickel plated brass, maybe. But this, I believe, is copper with whatever the silvery stuff is pressed into it. I'm going with nickel plated something. Nickel plated stainless steel. Because you want that middle part to be low thermal conductivity. Copper is super high thermal conductivity, which you want because whatever little heat does get through the narrow part, you want to get out of it into the heat sink as quickly as possible to keep the filament from melting up here and clogging like I just did. Because I printed with PLA at 260. Don't print with PLA at 260 because then you're going to spend 2 hours in your shop making a stupid video for 7 people. No, more people than 7. I'm going to look at it. I'm betting. Maybe 8. Anyway, so you want the narrow part to be as narrow as possible, so it has the least cross-section area to reduce the heat flux as much as possible, and also you want it to be as low thermal conductivity material as you can for the same reason, to reduce the heat flux as much as possible. And flux just means how much moves through over time, or maybe it has nothing to do with time, but it's a continuous motion of heat, and it can be other things, magnetism and things like that, I think. But anyway, definitely heat flux. And just picture heat moving up. I'm going to do I ordered a thermal camera, and I'm going to do a little experiment that I have a set of doodads from an old thermal management vendor that gave us this little sample thing. It's really neat. And so I'm going to do an experiment when my thermal camera gets here. I want to use it for all kinds of cool stuff. But anyway, so you want that narrow part to be as low thermal expansion as you can. No, not expansion. As low thermal conductivity material. That's, there's always a bunch of trade-offs. You want it to be strong enough. You want it to be blah, blah, blah. And so I'm thinking stainless steel is pretty strong, but it's also relatively quite low thermal conductivity compared to other metals. And steel is similar. But like aluminum, very high thermal conductivity. Copper, even more high thermal conductivity. Silver, even more. Gold, I think even more. Interestingly, diamond, super high thermal conductivity. FYI, for whatever that's worth to you. Like if you have an ice cube, I remember seeing a video with ice cube, and they had like just the heat in your hand holding a piece of like aluminum, and it's really slow melting through the ice because the heat of your hand conducting thermally through the chip of aluminum or whatever, and it melted the ice very slowly. And they did the same thing with a sliver of copper, and it went through a little quicker. And they had like a diamond chip, like a flat, like must have been a synthetic diamond, and the thing just cut right through that ice cube like butter. It was like unbelievable. Anyway, it's probably enough on thermal conductivity sermon. Time to put it back together. Where's my boron nitride pick? Well, let's think about what order this needs to go in. So this is going to go in first, I think. And I could probably put this together, put these screws in while it's apart here. Put those screws in, put the sock on, put those Teflon tubes back in, put that up to there, and put those screws in. Yeah. And so I think I can do that. So I'm going to do that, and then I'm going to get it I'm going to get it like 99% together and realize that I forgot to put the plastic Teflon tubes in there, or something's a showstopper, and I have to take it all apart again. But I'm going to risk it. Where's my boron nitride paste? Boron nitride paste. I'll slice engineer. And that's cool as Nathan does robots, because he's got a giant jug of it. He actually bought a big jug of. I wonder what he does. Like, he must do that. He must have a robot company, because he's got a big workspace and a million printers and stuff. So he must be doing pretty good for himself. He's a pretty young kid. Into sex with robots. Whatever. To each their own. No, I'm just kidding. Funny interview with Lex Friedman. Actually, somebody interviewed Lex Friedman. If you don't know, Lex Friedman is a super interesting interviewer, like super smart. He's a robotics and AI programmer, and he has a podcast. It's a super interesting podcast. Not always. So sometimes there's a little different theme to the interviews, but it's all interviews. It's like all long form interviews. It's sort of like Rogan, but smart. But so he has a bunch of like scientists on there, and it's super interesting stuff. Great interviewer. Well, this morning I listened to an interview where he got interviewed by Andrew Huberman. I'm not a big Huberman fan. He just seems kind of pretentious, and but excellent, super interesting interview. Because usually you hear Lex interviewing people, and so you don't hear a lot about what Lex really thinks. He mostly just asks people what they think. But that was a super interesting interview. Oh, sorry. As I said, so I don't want to get any boron nitride tube inside the heat break. I'm not sure if it really would be bad, but just in case. So I'm just sort of plugging the end of it by putting it in the hole there, and putting some on here. Like I said, I don't want to put too much, because you don't want to get it on the narrow part. Because if you get on the narrow part, you're defeating the purpose of the narrow part, because the thermal paste, the whole point of this thermal paste is to conduct heat. So if you get it in the narrow part, then you're going to conduct heat where you're trying to not conduct heat. You don't need much. So I'm trying not to squeeze this syringe too hard, because it'll come flying out. All right, there we go. So that's probably good enough. Let's see if I pork it a few times, see what happens. Oh, look I get these big blobs on there now, and I'm flirting with a disaster, Molly Hatchet style, trying to get it on the heat break portion. So I'm just kind of spinning it around, trying to get it in there as much as possible without loading it up. How does that look? Not enough. I think I need to do it. I think I need to put some on the inside of the hole, even though that scares me. This just is not cutting it. I'm going to wipe that off before I accidentally get it on the heat break portion. This is the military spec flight rated paper towel. It's also metric. I got a little bit on the heat break. Not totally disastrous, especially because it's still apart, so I can just wipe it off. Alright, and so I wiped off all the boron nitride that I put on there. Good job. Let's try this again. And I'm just going to put more on this time and start at the end. I mean, it may not be super critical, but I mean, if you mess this part up and you put too much paste, you are degrading the performance and you cause yourself clogs. So it is worth being very cautious to get it only where you want it, to get plenty of it, but also only where you want it. That's pretty blobberous blob. This is a technical term. Alright, I'm only going to put it at the top. That way I don't accidentally get any at the bottom. Put the cap on this guy. Interesting thing I learned, this thread is called, what do they call it? Lure lock. Lure lock. They use a lot of medical stuff. And I didn't do a lot of medical devices, but I had a couple good medical device projects recently. One really good one. And learned about lure locks. Neat thing. Look it up. L-U-E-R lock. Alright. I kind of want to put some on the end. But I don't want it to dry up and then cause a problem inside, so I'm going to not. And I'm tempted to wrap this aerospace grade paper towel around the heat break, so that way when I screw it up I can just pull the paper towel up and then the heat break will be, I just got boron nitride all over my fingertip. Not how I drew it up. Alright, that should do fine. So it's boron nitride paste on my fingers. And let's pork this thing again. We'll give it some wiggle action. It always improves the porking. This is not scripted, believe it or not. That is industrial grade comedy. Entirely unscripted. Look at that. That actually, the paper towel trick worked freaking awesome. Highly recommend that. Highly recommend that. And I don't mean I'm high. I just mean I recommend it greatly. And I need a wrench. Tighten this set screw, although I need to align it properly first. So let's rotate that around. Get it about right. I'm just going to snug it up a little bit so it doesn't fall out, and then I'll put those other two screws in. One here, and one. Oh, no. No, not the right hole. Oops. And I have boron nitride in the screw holes, but that should be harmless because they're going to conduct anyway. And that just went all the way in without screwing into anything. So I guess it turns out I can't screw that in yet. But what I can do, is use those to align this for now, and then tighten the set screw, and that will hold the heater in there while I ruin everything else. So I put those in this to align it, and then I'm going to tighten the set screw. I don't want to go too crazy, but you don't want it to come out either. I don't have a big wrench handle on it, so actually I'm going to put a big wrench handle on it to get a little more snug, and this is when I break it. Just a little more torque on there. Make sure that doesn't come loose. Alright, we are cooking with gas, which I think they're outlined, aren't they? Which is funny. A good friend of mine is a propane accessories guy. Ooh, whoa. That was, so it's kind of a touchy subject when they announced outlawing propane. The gas stoves when my buddy makes his living servicing propane and propane accessories. Alright. Alright, so let's get those two screws back out of there before they get themselves out of there when I'm not ready for it. Whew, I'm hungry and my legs are tired. I actually went running this morning, so my legs are tired anyway. And now I'm going to stand in place for 17 hours. And boy, are my legs tired. I'm not a big runner. I was never a big runner, but I took a bunch of years off, but grew up playing hockey and got back into it like 20 years ago. And 17, 18 years ago, something like that. Anyway, it's easy to get out of shape, and then hockey season starts and you're ready to die. And I'm actually back in 3 leagues again this year, so you get back in shape in a few weeks, especially playing 3 times a week. But you definitely can be more competitive if you come in with a little bit of better cardio. So I bought myself some exercise and bought myself a nice little power cage to do a bunch of weight plates, and I already had some barbells and dumbbells and stuff. But so training for hockey season, and that's why I went running this morning. Nothing major, a couple miles. So don't forget to put the silicone sleeves back in here, because you'll totally fail at printing and wonder why until you notice these things sitting on the bench and you're going, where did those come from? Right here. Ah, you don't see what I'm doing. So I'm putting these Bowden tubes, saying it, in the hole. Insulator tubes, thermal insulator tubes. I think I did a pretty good job with that bar nitride. I'm happy about that. And so then I think if I do this, then I should be able to, what are those screw into? That, yeah. Okay. I mean, I guess I'll put these bigger screws in first. And of course I have a million screws I took out, so I have no idea which screws those are. So I always keep track of which screws goes where. I thought I was going to take out like 5 screws, and I have like a whole pile of screws here. You can check out my pile of screws. My Weeha super tool box. Which screws are those? Which 2? You tell me. Alright, so I know these are for the fan cover. These 2. It ain't those. It ain't this. Could be this. It's not that. It's not that. Could be these. Are they flatheads? They don't look to be countersunk. Are these flatheads? Or are they just confusing me? Those are flatheads, meaning they're countersunk. Yeah, focus. Focus. I mean, I'm focus. Why not? Why won't we focus? You can see the underside of this head is angled. Oh, it almost focused and then it went away. Underside of this head is angled. That means it's a flathead screw. It's flat on top, angled on the bottom. I can't let that go. And I believe those are not. Or they might be. Let me look. Yeah. That's Chinese. That's Chinese. What? WTF? Yeah. In my past life, I was a pizza delivery guy and a Chinese food delivery guy from the day I got my driver's license. That is hard to even tell if that is countersunk. I think those might be the countersunk ones. It's just hard to tell looking at it. Where else do I? Do they look the right length? They look that looks like it's longer than it needs to be. Oops, I should have paid attention. There's only one of this one, so it's not that one. We got a bunch of these look identical. Three of them hold the extruder in. 3 of these hold the extruder in. The other 2 I'm not sure what, so I'll put the 3 of those over here. I have 2 flatheads. I have this one long one, so it's not this one. Why is there? Oh, these long ones hold the PCB on. Now I remember, because one will. Yeah. So these. Wow, they have 3 different lengths of holding the PCB in. That's pretty freaking. Oh no, wait, no, that's the flathead. Why do I look like I only have 2 screws holding the PCB? Please tell me there's one more in here, and there's not. I may be missing a screw. I'm not sure. We'll find out. How does this go? This goes here. I'm trying to find out, figure out how this goes together. So this guy goes here with those two screws, and they look like those screws don't need to be very long, but they look like they might be flatheads. These are not flatheads. I can see that these are not. And these go. This goes. Is it like this? Oh, there is a threaded hole right there. So this goes like this. What am I? Something's going on here. I have something backwards. How did this? So these, yeah, it's oriented like this. Oh, okay, I didn't go up high enough. Again, not doing drugs right now. And so that, why is that? There must be, there's going to be something in between, because that is not bottoming out. It's bottoming out on that. What am I missing? What am I missing? That hits. So this connector, where the connector where the fan is bottoming out on the belt mount. So what am I doing wrong? These are recessed. I need a spacer of some sort. What? I'm missing a part? Am I missing a part? Am I just, does this go up higher? No. What is up? What? Huh? That can't be right. Kids, pay attention when you take stuff apart. Take pictures, video, pay somebody else to do it, whatever it takes. That is bottoming out. That does not make sense. It goes there. I guess nothing plugs into it. I hate when they have connectors that don't get used, because then you don't know if you're doing something wrong. What? Extruder shouldn't matter. That's all in the back. Yeah, that's all in the back. This goes on last. Or second to last. Oh, two spare screws for the to mount the heater. What? I don't understand what. Well, all right. I'm saying I think the screws for the PCB were varied in color, and so I'm saying the two flathead screws do go here. At least I have answered this question for myself with a high level of confidence, somewhere around 51%. So we'll put both of these guys in there, and I'm going to reach my wrench, and I'm going to sneeze, and those are both going to go flying, and I'm going to have to buy a new printer to be printing again. Where's my little tool here? Oh, goodness. And the ratchet. The right size? It is the right size. That doesn't seem to want to go in very easily. I'm not sure that that's the right screw. I think that's not the right screw. I'm going to pull these out before I break everything. And I lost it. Can I lose this one too? Nope. I'm going to have to try harder. Let's find that screw I just lost. Oh, I see it. Where's my stick? Where's my magnet on this? Custom made magnet on a stick. What do I do with the magnet? Oh, it's back in the thing. What are you watching? Oh, turn it, okay. Put the magnet on the stick. Like, I'm freaking old. You know how many screws I've dropped? You'd think I'd stop dropping screws. No. And the magnet's stuck to the motor. with the screw. So that's not how I drew it up. At least I got the screw out of the crevasse. That sounds sophisticated sometimes to fool people. So those were evidently not the correct screws for that. So evidently that is not the flathead screw holes, which I should be able to tell by looking at it, but it's just shiny and I can't tell. So I'm saying it's these other two little screws that are the same as mount the... What, 3 screws are mounting what? I don't know, I'm hungry and my brain is stopping working. Does that go in there? Yes. Does this tool move it? No. This one must. That tool moves it. Okay, let's just put this in here. This one doesn't really seem to want to go in either. Did I strip that screw out? I mean that hole? I don't think I put that much force, although it is a tiny little screw. So I'm just gonna... What is the joke? Cross-threading, Redneck's version of Loctite. Yeah, so it's going in the side easier. So I may have very slightly fouled that thread, and so I'm gonna put Redneck Loctite, cross-thread this bad boy in, and call it perfect enough. It's going. Just a little bit of resistance there for some reason. Could be just with a class A thread fit. I think so you'd have like a, well, these are metric, so it'd be different. But in the imperial inch sizes, you'd have like, you'd call it like quarter 20, quarter inch to 20 threads per inch. UNC for United National Course, or Unified National Course dash 2B is like a standard drilled tapped hole, and it's kind of loose, so the thing can kind of wobble around. It's easy to put in and out. But if you need it to be really tight, you call it 2A. I think the 2 means it's the female hole, and the A or B is how tight it is. I don't know. Tell me in the comments if you like my mechanical guidance here. I'm still gonna flap my gums even if you don't. But I just like to talk about stuff like that because it interests me, and maybe it helps some people. That might, because there might be some people that are considering a career in engineering type stuff, and knowing this stuff is extremely valuable in that trade. Okay, so I still have a lot of screws left. Those are for the cover. These are for that. Okay, I can put these 2 in there. And which tool is that? That is the little tiny one. That's not it. That's not it. That's not it. Where did that little guy go? I'm using an actual hex key. Oh no, I didn't. I used this. I used this guy for this one. So he's still on. Are we pointing at a good place? Oh, sorry about that. You can fast forward past that part. This is so long, I am not going to watch this to edit it. I am just going to post it as it is. Oh, I can't, that's right, I can't use that one because it doesn't fit past, it's too wide. I need the actual little hex key, which I've evidently lost. I'm not an entirely clutter-free type of person, which bites me a little bit sometimes, but I know it's so. So hopefully I can get these started, even though I already set the set screw, but I tried to align them pretty parallel, and so hopefully they line up with the holes, and I feel like it's going in. And I didn't mean like my touchy-feely feelings. I mean it feels in my fingertips like it was going in. I like to think about things rather than feel them. Like I feel like something. No, I think something. Think. Use your brain. Don't just go by your emotions. Emotions will fool you into doing dumb stuff. Sometimes it's fun though. Anywho. That is in there. We are getting closer. Although, I still don't know why there's like a gap. Oh, the fan. Haha! I knew there had to be something in there, and that makes sense why the screws are longer, because the fan goes in behind the PCB assembly, and the holes go through both, and the screws go through both holes. And this goes at the bottom. I just remember from fighting with it one day so hard. It was horrible. And I decided, remember, I'm going to plug this in before I put it together. And I'm going to thank myself later. Now, the project's going to fall out because the connector's broken, like I showed. The PCB side connector. But I'm going to try it anyway. So the thermistor one is still in good shape. Maybe. I think it goes that way. Yep. Definitely. I think, I can confirm myself incorrect in a minute, but I believe it's much easier to plug these in while the PCB is not connected, not mounted, because it was so hard to get that's how I ended up breaking it, because it's so hard to get at the connector with the PCB mounted. Is that pulled that out. That connector is upside down. Why would they do such an evil thing to me? Alright, I just twist the wires like crazy, and that connector pulled right out. So as I was concerned already, that I almost want to screw in the hole first to align that, but I'll probably be okay. So I twisted that around so the connector is now facing the correct direction. I'll put it in the connector, and then I'll put this on, and hopefully the connector, I don't want to push on all these electronic parts with my thumb, but they don't leave me much choice, do they? Holy cannoli. Let me put this Bowden tube in there so I can sort of push on that, and maybe less chance of damaging things. I'm not sure. Let's connect this guy just because I think it'll help me a little bit, maybe. I'll have to push that in, and I'll forget to push it in, and I'll put it all back together. It's not going to work, and I'll have to take it all apart. It's going to be awesome. Alright, so let's get one screw in there just to get going. And what are those? Okay, I still have these two flathead screws. I have these two screws. Why? It seems like I either have an extra screw or not enough screws. So I need to actually, these are a different length. That's nice of them to give me two different length screws. So I actually have to take this back off to figure out which screw goes where. Which screw needs to be longer. I'm going to unplug that again. Those two appear to be the same length, and that one appears to be longer. Are those the flatheads? That doesn't make sense. It's going to be these guys. I got to be missing a screw. Okay, let's get rid of some clutter one-handed while I hold this here. Figure out if I'm missing a screw. I'm gonna get rid of everything. Yeah, good idea. Put them on the bench. Good job. Alright, so I mean, all of those have a seat, like a grounding pad on the PCB. So those all three, I have a hard time believing, would be for flathead screws. I found it. Alright, so I have two shorter ones and a longer one, and that makes sense. I was thinking the top ones would be the shorter ones, just because of the way the threads are. So if you look here, these two go into these. Can you see that? Can you focus? So you have these two brass, these are heat set, I assume, nut inserts, thread inserts. And so those are more proud, they stick out more than this hole here. Can you see that? This hole here is further in, so that's the longer screw. And the two shorter screws go up top. Oh, we are getting there. We are getting there. This is how not to do stuff. No, actually, I mean, what are you going to do? What can you do? You just got to figure it out as you go. And these connectors came out as I predicted. But at least I noticed it before I put it back together. Or one of them came out. Why couldn't the other one have come out? Yeah. As they used to always say in the kitchen at the Chinese restaurant. They had a bunch of Chinese people working in there that didn't speak English. The owner spoke English, a young couple. They're pretty nice for the most part. And of course, anybody you work for seems not nice sometimes. It's just the nature of working for somebody. Not always, though. I tend to pick my clients wisely. But when you have an actual job and you're a slave to the corporation, then you're lined up to be a victim. So anyway, different strokes of different folks. I quit my job 7 years ago. Very happy. Six and a half years ago. 6.5 years ago. And haven't looked back. Although the first year didn't make a dime, burned through my retirement. A little scary there. A little touch and go for a minute. But we made it so far anyway. Don't quit your job unless you have income. I quit my job without income. Don't revise it. Get some income on the side and then quit your job. Why is this not wanting to go home? Go home. It's like doesn't want to go home. What's going on? And these things, I mean, I can't imagine that's still connected. Oh, they are still connected. What a miracle. I'm still holding this piece of Teflon tube in my hand. And because I can't really help it. Do I need to pull this away? Why does this seem to not fit back there? Maybe I need to put the fan first? That doesn't really make sense. Maybe I need to loosen up that bit. Holy cow, my deltoid muscle's getting tired. Why? Go home. I need to lean on something. Those will wind up. That just doesn't fit. What the hell? I mean, maybe... I took it apart this way. It's got to go back together this way. My hole's not lined up. My fan holes. Let's put one screw in here. That might help. I hear a noisy muffler car. I assume it's across the street. Not here. In a pretty rural area. It's kind of nice. Not a lot of traffic. If you could hear that car, that's like the one car, right? Why? I'm going to loosen those screws. I don't care. These screws up here, wrong tool. What did I just throw on the ground? I don't even know, and I can't look because my hands are full. I don't want to take it all the way out. No. Get back in there, because there's springs behind these, and those things are a pain to get back in. Wicked pain. All right, I think I got it. Let's loosen this one a little bit too. Remind me to tighten those back up. All right, so I just gave myself a little more clearance there, and hopefully that helps. And this screw that I wanted to help me is probably killing me now. Let's do that. Let's push this up, and of course the carriage always wants to run away from you too, because it's on linear tracks here. That does not. Is that lined up? That must be lined up. That's gonna be lined up. That's gotta be it. I'm saying that's it. Can I screw this in now? Can we just be done with it? I mean, we're almost there once I have that in. And maybe I want to do this long screw first. I'm really looking for trouble now. Some multiple screws that aren't in. That aren't started. It'll be the same size. It is. Alright. That worked. I'm going to. So that's sort of. I was just trying to get it further than it's supposed to go. All right. That one's probably too tight. I'll probably have to loosen that. I'm going to tighten these bearing screws back up. Bearing preload spring retainer. Preload springs retainers, one at each end. Whew! We're getting there. I hope this thing's still recording, huh? Yeah, looks like it. Nice. At least this phone doesn't cut out after 5 minutes like my old one did. And that wasn't like because it was breaking. It was just an arbitrary limit that they put on the record time. Probably a thermal thing. This also has more space. The old phone was 128 gigabytes. This one is 256. I may have misspoke the other day when I said I did a little unboxing of the new phone, and oh, please be still connected. Nice, my connections are still in. When I said that my new phone was $1,000 and the Samsung equivalent was, oh no, it's coming out. Is it? Coming out. And I said my Samsung equivalent S23 Ultra was like many hundreds more. I think the Samsung one might have been 512 gigabytes of storage instead of 256. So that might have been the extra few $100. And maybe I could have got the smaller S23 Ultra, if there is one, for a similar price. But again, I did like the camera better on the Google Pixel. And I never had a Google Pixel. I've had a bunch of Samsung phones. I think my last 3 phones have been Samsung. And I don't worship at the altar of Apple, even though Steve Jobs is phenomenal. And executive engineer, I guess I'm going to call him. Just going to make up my own term, what I would call him. But just not a fan of the way they lock you into things. And you get, like, generally, if you look at the specs for the hardware, oh my god, right now, I think I'm alienating probably 90% of my viewers. I mean, I love Apple. I'm in love with Apple products. I wish I could have bought an Apple phone. But why is this screw spinning forever? Okay, it's almost in. I see it now. A couple more twists of the old. Ow! Oh, how come we're not on camera? Sorry about that. The problem is this is on the XY gantry, and so I accidentally move it, and then it's off screen. But my hand's in the way anyway. You'd be better off if I was left-handed, because you could see the thing instead of my hand. Let me see if I'm talented enough to turn this left-handed. At least you can see the PCB. All right, there we go. Funny, I thought I had already tightened these ones up, but I don't know. I did not. Make sure all your screws are tight, not too tight. And I already did the other 2 at the heater. Technically, I can put that sock on right now, I believe. So these heater wires, the heater and thermistor connectors seem to be in pretty good. What did I do with that? Oh, that's the... I just noticed that annoying guy. Oh, I put another light on here. Look at that. This light is actually pretty cool. This is a Coast brand. I'm actually going to hit these guys up to see if I can get them to sponsor me, even though I'm barely in triple digits for subscribers. But I didn't realize they actually have a lifetime warranty on their headlamps. This is a Coast headlamp, super nice, very bright, and I've bought at least 5 of them over the years, and I love them because I lose them. A couple of them broke, and so anyway, I noticed that. So I bought a new one, and it turned out that they had messed up on the advertisement on their webpage, and so I contacted customer service, or somewhere along the way, I also realized I'm going to work and talk at the same time. Somewhere along the line, I realized that they have a lifetime warranty, and I was like, I got a couple of these things that broke, and I can probably get them replaced. I already bought a replacement for it, and I already have another replacement. So I have two, one like this, and one that I've had like 4 of, or 5 that I've bought because I gave one to my girlfriend, my ex-girlfriend, and so I realized they had a lifetime warranty, and so the guy's like, yeah, lifetime warranty, just take a picture of it. And I said, okay. So I took pictures of the old broken stuff. I always keep all my broken electronics in case I ever decide that I'm going to try to be electrical engineer and or tech, and need some electronics out of it or whatever. So I keep my old busted electronics, and so I dug out my 2 old broken Coast things, and I'm sure I lost at least 1 or 2, and I bought that other one for my girl at the time, and those are all the same model, the HL7, which is a great one, and I liked it because it uses AAA batteries, and it said, this new one I bought said it would use AAA batteries or lithium. And I told the guy, I said, I thought, because while I had him on the phone, I was like, hey, by the way, I can't figure out how to get the cover off of this thing to put the AAA batteries in. He's like, no, that light doesn't have that feature. You'd have to have the dual power mode for that. And I was like, oh, I could have sworn it said it, but okay, I'll take your word for it. And so then I looked on the webpage, and sure enough, the webpage said it had a feature that it didn't have, and it was expensive. It's like $80 light. The other ones were like 30 or 40. This one was 80. And I still like the light. I'm not going to return it, and I'm like, well, correct me if I'm wrong, but doesn't the website right here say? And I showed him. He's like, oh, holy cow! Thanks for showing me that. I'll get with my team right away, and let me know how you want to proceed. So I already had credit for 2 new lights, and I didn't need new lights. And then he realized that they sold me something on false pretenses. That was twice as expensive, and didn't say it wasn't what it said it was, and it wasn't anything bad. They have great products. I greatly stand by their products, and the guy was very apologetic, and he was basically like, let me know what you want to do. So like, I'm sure I could return this one for a refund, plus I have credits for 2 more lights, and they also make like some knives and multi-tools and things, and a bunch of flashlights. And so I'm going off the squirrel, where is it? So I am going to try to parlay that into getting a little bit of some kind of sponsorship. Maybe it's already going to send me. I already have credit, so I can already buy some products. I'm thinking of buying a multi-tool, or I could just get a refund. Actually, I could probably just tell them to refund the $80 for the new light and apply the $80 to return the other 2 lights. Which, if I was totally broke, I would probably do that. But I'm going to try to parlay it and get myself a little bit of show and tell sponsorship. Even though I already did it, I do have a video already showing the HL7 light and how much I like it, along with some batteries that I said it broke. But anyway, where did I go? I need to plug this in. Oh, there's the wire guide. Okay. There's the annoying wire guide. So I need to tuck these wires in. Tuck them in one at a time. Let's see if I can get this on film, even though there's no film involved. Alright, so if I can keep it right there, like, what's the chances of that? Can you see that? Can you see that little nubbin? Oh, why do you not focus sometimes? It's right there. There we go. Let's get the light on it. It's just a little nub in here. No. This little guy right here. You gotta tuck the wire under, where is it? Between, come on. You gotta tuck the wire in here. And it's kind of tricky, so you just do one wire at a time, makes it a lot easier. Don't try to stuff all 4 in. You gotta kind of zigzag it around this. So, just one wire at a time. Whoa. Let's screw that in first, and then we'll go one wire at a time. Isn't that what they say at AA meetings or something? Alright, so I have 3 of these screws left. And there happens to be 3 screws required for right here. What a coincidence. Need a bigger tool there. So probably not on film. Well, you got my, there we go. Putting the 3 screws back into the Extruder. Screw 2. If it's lined up, it seems like it'd be a miracle if it was. It's going in. I seem to remember last time I put this in. Oh, and I do have a newer extruder, but I think this might be the latest extruder anyway. But I'm going to say if it ain't broke, don't fix it, and go with this, because I actually did a really good print yesterday. I don't know if you saw that. Well, finished this morning. Big pile of ASA prints for my new DIY build. So I'm so glad I'm able to get this together, knock on wood, and it's going to be working again without me waiting for parts forever. Does this have a weird echo? Cause what I had to do is, so I couldn't hear the audio and the playback the way I have it set up. And so, geez, I hope I didn't mess up the audio. I think I did sound checks, it should work. So I actually have my wireless mic clipped to my shirt, but I also have my headset on, so I think I'm going through two mics. I think that might be why it sounds a little goofy. So hopefully it doesn't sound too crappy. So that is in. I don't want to put the Bowden tube in yet because I don't want to forget that I did route these wires through the thingamabob one at a time. No need to rush because it's just going to cost you more time. One at a time, I said. Alright, I give up on one at a time already. Anyway, you'll see how they have to come out and go in. I'm going to use my right hand because it's on the right side, so it just doesn't make sense to use my left hand. Alright, there's one at a time. And get in there. Two. And that's not in there. I think I could do two at a time. See, I said don't rush. Didn't I just say don't rush? No, I'm trying to rush. Okay, there's two. It came out. No, come on, three. Give me three. Almost. Three. And come on, four. Get in there. It's like bent the wrong way. Get in there. There we go. Alright. It's almost as if I kind of know what I'm doing. Almost. As if. Alright, we'll get that connected. And we are almost back in business. Even though this is not my business. I cost a fortune for all this stuff that I don't make money on. I've wasted so much. It's funny. It's actually for the. Where does this actually plug in? I don't even know where it plugs in. I see a wire guide here, so it almost seems like it would go around here, but it ain't long enough to go there. Where the hell does it go? Son of a biscuit. I don't know where it plugs in. I totally don't know where it plugs in. Am I going to have to watch my own video to figure out where it plugs in? It doesn't reach there. I mean, it has to. It comes through there. It's got to be right there. It's got to be right there. I see. Right next to the heaters. I see. Does it go that? Oh, it goes there. Yep. All right. So I'm gonna try to get this on video for you, just to show you, so you don't stress like I did. See that? It's gonna plug in right. Oh, you kind of can't see it because of the rod. Can you see it now? Almost. Focus. Focus down there. Yeah. Ooh. Yeah. And so, what I have to do, so you don't want to go out, I believe it doesn't go around the outside. I believe you go under the heat sink. And then, whoa, this red wire, don't put that around that. I feel very thirsty right now. Last of my water. I better finish pretty soon. I'm going to dehydrate and shrivel up. I think this is supposed to go around that way. Am I like on the wrong side of the other wires? No. Is there actually a passage through? Oh, there's not a passage through there. Can that even reach that? I guess it does go around the outside. I don't think it's supposed to go around the outside, but I'm going around the outside because it doesn't reach. So maybe it is supposed to go this way. I don't know. Well, at least I plugged the other two in while the PCB was not attached, because this is also going to be a hassle, but at least the other two are attached. I'm going to use these giant tweezers. Maybe I can get it in that way. Let's just grab it by the wires. And that doesn't work because the other connector's in the way. And this is a horrible idea. What if I grab it by one of the wires from this side? That glue is a pain in the neck. This side broke the other connector. But I couldn't see what I'm doing. Now at least I can see it when I break it. No, it came off good. See, the funny thing is though, they'll send you new parts, but they don't send you the new glue. So now you have your wires connected, your connections connected that aren't glued as they were from the factory. I did ask them about that. They didn't respond to that question. They generally don't respond to technical questions. They'll respond to, you know, general questions, but all right, I'm just gonna grab by the last wire, I think. Can I grab by the wire? Not recommended, but I don't have much choice. Ooh, is it that easy? No. Very finicky. Very tricky to get this in. Is it in? Is it in? Probably not. No. No. All right, let's do that. So I knew that it'd just twist if I hold it that way. Is it there? At least if I can line it up, then I can just shove it in. Is it the right way? Where's the guides? There's no guides. Thanks. Oh, the glue's on the side and the glue's on the side, so it goes this way. Can I just get it like this, please, please? Oh, they don't give you any access. And you can't do this one. I say that. I don't think I could have done this first before the PCB. Maybe I could have. I don't know. But at least this one's easier to get at than the heater ones, slightly, not by much. Holy cannoli. Can I put my arm through the back of the machine? No. Yeah. Yeah, good luck with that. That's tilted. My back is going to break in half in 5 seconds if I stay like this. Holy cow. Somebody dial 911 and wait for my signal. Why are you so difficult? Ooh. Plus it doesn't help that my freaking ISO is starting to go. So just when I think it's lined up, I could be ½ inch off. Is that in? I think it's in. See, you don't always have to see the hole to get it in. Why is there... Oh, I forgot about those. Where are those? Oh, there's the screws. Oh, okay. Those should be easy to get out. Oh, my back is a little tweaked at the moment from doing that. I forgot about those 2 other screws that I removed. Let's throw those back in. And they were basically holding the heatsink into place, I believe. So let's do this. Let's refocus on the raised stuff. Oh, there's the heated bed assembly that they're supposedly sending me, which I have not seen. I don't think they give you much for tracking. Where is it? Oh, there it is. Alright, focus. Right there. Alright. I could have noticed that I had a couple screws left. Oh, that's these. That's where the long flatheads go, and I think those just go into the heatsink. So hopefully they're lined up enough to go in, because otherwise I'm going to throw this thing. I'm going to climb up on the roof and throw it off the roof. True story. Oh, there it is. Please go in. Please go in. Please go in. Nice. I'm actually 1% Australian, mate. I'm actually not, but my niece, no, actually, she married a New Zealander. So So much for that. But they still talk sideways. Why is there seems to be, oh, those, I was like, there's extra heat set threads there. What am I missing? And those are for the front cover. I think we are almost in business. Oh, I'm going to put the thermal sock back on. Give that a little snug. Give this one one more little snug. Perfect enough. Silicone sock. Highly recommend this brilliant technique that I just invented today, which probably everybody did it except for me until right now. Put it inside out. Pull it off inside out, and then leave it inside out. So when you put it back on, oh, I hit the camera. So when you push it back on, it's much easier. See, it's inside out still. Silicone sock inside out. This seems like it might be more durable than the black one. Tough to say. Is this symmetrical? It is not symmetrical. I can see the little flange, so it matters. So if you bend it, this little trick, I just figured it out. Maybe you would anyway, but I'm going to show you because I just figured it out. So if I bend this like to here, I can see this little nubbin here on this side and not on that side. So that tells me that it's going to arc out, so it's going to have to clear something. And on the back side of this flange is a similar contour. So this goes to the back. And so I'm just going to line this up ahead of time. Stick it in there. There we go. Now we're talking. Look at that. You know, it's funny. The first time you take a hot end apart on any printer, or for myself, first time I take a hot end apart on any printer, I'm like, oh no, this is so daunting. Which, you know, if you want to see daunting, try changing your ball joints in the slush in February onto your truck. That's I've done stuff like that. Way worse. Way worse. Anyway, that was back in the day. Cars weren't as reliable as they are now. Back in the day, you used to work on your own stuff all the time. Of course, it was when I was younger and broker and had 200,000. That truck I'm talking about was like an '88 Dakota. It had I bought it with 197,000 miles on. True story. And truck almost killed me. I say it almost killed me. One day I was working on it under the hood, and I happened to notice this rusty chunk of something with a big crack in it. I was like, oh, what's that? And I look, and it's a universal joint on the steering column. And the collar was cracked all the way to the middle, and to the end, to the U-joint part. And I was like, holy shit. That thing's ready to let go. And I was driving to work every day 80 miles an hour on that truck. And I happened to just notice that the steering coupler was cracked almost in half. And I was like, oh my God. So, yes, I bought a new steering coupler. That was probably a much easier project than all the other things I did to that truck. But it's a great truck. I paid $500 for it. It was 4x4. Had the bigger motor for the Dakota. And it hauled ass. And it's a good truck. Had power windows, extra cab. All right, anyway. Meanwhile, back at the ranch, we are mostly together. I got to put the covers on. I have 2 screws left. That is the proper amount of screws to have left. It's a Christmas miracle. I'm going to plug this connector in. Can you see what's going on? I know you tuned in to hear my old Dodge Dakota repair stories. Whew, I'm hungry. Thankfully, I have half-eaten, still have to go, extremely delicious homemade bacon, egg, and cheese jalapeno burger. It's in my fridge with my name on it, just waiting. And it doesn't actually have my name on it, but it's my fridge, so. What is that? Oh, that's part of the cover. Okay. I was just feeling something there that made me nervous for a second. The closer I get, I'm getting nervous. Because it just seems like success is imminent. So that could be false sense of security. And it could be a meteor. It could be about to land on my shed for all I know. This always seems a little tricky to get started, but I think you just need to push it on. Are you still on the camera here? So if you push this with your thumb, then the hole lines up pretty good. Oh, I think that's actually what I was feeling. It's like a little foam pad. Oh, that's what it is. No, maybe not, because I thought it was in, but it's not. Okay. Unless I stripped it. Or it's just not in. Okay, it wasn't. So it's hard to line these ones up a little bit. Just push on it. And so you have to compress some foam, and I guess it's sealing up this duct to improve the airflow. So you get like an air leak if you don't put the screws in. You get an air leak, and that will degrade your cooling, which will degrade your printing. And so again, I'm going to put it in the hole, but then I'm going to push this backwards to press that rubber, and now it goes in the hole easy. It's funny, I've done this about 10 times, and this is the first time I thought to do that. It actually worked. Usually I'm like fighting it, and so now I remember. Okay, that's all the screws. Put the Bowden tube back in the Bowden tube hole, and the blue clip. Are we still on camera here? Sort of, kind of, maybe. Let's zoom out a little bit here. This camera is, when I was playing with it yesterday, I was like, God, this thing focuses awesome when you zoom way in. And now I'm less impressed by that because it seems to be out of focus a lot. Okay. Whew. How is it that I just talked for how long straight? That's a miracle. How did I come up with? And it's not even like I'm trying. Just stuff just comes out. Don't you feel bad for my friends? That's why they like me. That's what I want to tell myself. Come on now. Ta-da! Let's wiggle that around. Make sure that's at the top. Nailed it. All right. That is all of the screws. I'm going to put these heaters away. I think both of these heaters are still technically good, even though this one, the ceramic is cracked a little bit. But it looks to me like the circuitry may not be broken. And, I mean, I was just printing with it, so I'm going with it. Oh, it's cracked on both sides. Holy cow. So, interesting. Surprised I didn't damage the silicone, because I imagine the ceramic probably also protects the silicone a little bit. Maybe it doesn't even protect it. I don't know. I'll put these nozzles back in a box over here that at some point had nozzles in it. There it is. And the sock. Also, we are good to go. What is this? Oh, it's a soldering tip. Oh, I got one last cover. No, I forgot the blue bone tube. Ah! 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 All right. Let's. Didn't I say I was going to get it all the way back to the? I said it was going to be the white silk, the white Teflon tubes that I was going to forget to put in. It was the blue one. It was the blue one. But that's only. I think that I just only popped the extruder out back in. Yes, thank you. Oh, thank you. It's just the extruder. Just the extruder. Okay. Let's walk this back a little bit. Reposition the old Camerooni. Do this. Start with this one, so at least you can watch out mosquito. So you probably don't have to watch, but I'm sure this is such an extreme level of entertainment that how could you turn it off? And it's only going to take another minute. And we'll fire it up and test it. So you got to see, you got to watch it, you got to stay and watch it, see me fire it up and test it, right? It's only 3 screws, and then shove the Bowden tube in, and then put the 3 screws back in, right? So I'm going to put that screw there so I don't lose it, even though it's a little awkward to reach. What is on my butt? Oh, there's a thing on the table. Tipped over and was leaning against me. That's one screw. There's another screw. Another screw. Weird week. 2 people in a row. That one is my nephew, and one is this girl that I graduated high school with that I hadn't seen in forever. Have product ideas. And kind of, it's what I do for a living. So it's like, you want to help people. But, I got to take. Oh, no, I scared myself. Good. Yeah, you want to help people, but that's actually a significant amount of work to do design work. And so try to advise them and help them a little bit. And gonna be able to keep up with my regular client work. But what are you gonna do? You gotta like even lawyers do pro bono work, right? So this thing is all wallered out. Can you see this? I kind of wrecked this Bowden tube. I'm hoping I can wedge it back in. You see how it's like a flare fitting. It's all flared out, and I was hoping to put that end in the bottom. Actually, I may be better off. Yeah, I think I'm better off putting that end in the top. Although, will it go in the top? Yeah, I'm gonna have the same issue either way. Yeah, I think I might be better off in the bottom because then I can force the filament. So I'm gonna. Yeah. Maybe I need another piece. Do I have? I gotta have another piece of. Do I have another piece of blue? I think I have a brand new, an entire new blue one. I think. I don't know exactly where it is, and I don't feel like taking the time to look. I'm gonna make this work. I'm gonna twist this, and effectively make it a smaller diameter by twisting it and squeezing it. And that's a horrible way to do it, but I think the filament should potentially push it back into shape. Is that enough? Hear my cat making noise out there, like he wants to go in or something, like he's talking to me, or he's talking to somebody. Maybe the dog is at their door, or and he's talking to the dog. Just kind of a friendly meow. Now I hear him. Godzilla, what's up? Godzilla. Sorry for blowing out your eardrums there. Oh, it's not entirely cool here. Please go in. I could modify that hole a little bit to give me a little lead-in chamfer. That would help. Bad idea. Seems. Did that do it? Godzilla. Where are you going? Oh, he's right there. What are you doing? Come over here. He probably thinks he's in trouble because I only call him Godzilla when he's in trouble. For the most part. If he's picking on his little sister or something. But it turns out it's usually her fault. I figured that out. It took us a few years to figure that out. She'll hiss and I'll be like, leave her alone. And it turns out he's just being friendly and she's like, get out of here. Right? I don't want to go in. Maybe. Ooh. If I slid it ever so slightly, and I was going to say in 2 places, but maybe even 3 places. If I slid it there. Now I did it. And I'm going to do it 3 places. Slid it there. Is this on camera? I slid it here. So I did it 3 places, 120 degrees apart, which equals 360. So evenly spaced 3 slits. And I'm hoping I can kind of squeeze these together now. Just enough to get it to start in the hole. Because this thing is flared out like a son of a biscuit. It's funny, I was talking to a guy about printing I was going to buy the printed parts for my DIY kit because this thing was giving me trouble with under extrusion. And I was like busy enough and to print all those parts, blah, blah, blah. So I was going to hire a guy. And then I did the firmware, which seemed to fix it yesterday. So I told the guy, he might be a little mad at me because I kind of said I would do it, but I didn't pay yet. And so I said, well, sorry. That worked. Nice. Bam! That worked. That, you can take that. Oh. What's going on? Turn on battery saver. Is that going to stop my video? Turn on battery saver? I gotta hurry up because I can't plug in the charger because the mic is plugged into there. And so let's go. What, oh, that's the, I gotta twist this around. And what was I saying? I forgot what I was saying. Must have been super important. Alright, let's get the screws back over here. So no battery saver mode now, so I'm not sure how long this is gonna, how much longer it's gonna record. Alright, they went into the Bowden tube. What was I saying? What was I saying? What was I saying? I don't remember. Ooh, I'm so hungry. I'm so hungry I could eat a bacon and egg cheeseburger. Nah, I live on those things. Since I bought my grill, like, I don't know, end of spring or something. Bacon and egg cheeseburgers, baby. It's so good. You take the, take some couple cloves of garlic, dice them up, like a sixth or an eighth of an onion, depending on the medium-sized onion. Half of a medium-sized jalapeno or so. Dice that, chop that up into half rings, and is this on camera? Sort of. And put some butter on the griddle. I mean, you're going like, holy cardiologist. I don't care. It's delicious. And I think a lot of those, the studies, they group these old studies that everybody relies on for fat's bad for you. Or they group burnt French fry grease with animal fat, and I call bullshit. And I feel like $100. So there. So I like my grass-fed butter, and yeah. And everybody's like, "Oh, I don't eat margarine." Yeah, well, turns out margarine's freaking poison. Huh? They didn't tell you that when you ate that forever. Oh, but eggs are bad for you. Bullshit. Bullshit. They just want to sell you stuff in a box. They just want to sell you every food in a box. I just eat vegetables and meat for the most part. I did have a pizza the other day that I made on my griddle. And the crust was too thick, and it was... The other, actually the Paul Newman pizza, it's actually pretty good. It's like a thin crust, and it's got good toppings. It's actually really good on the griddle. I'll buy 1 or 2 of those a week. Put those on the griddle. Sometimes with shaved steak. I actually get a lot of views. I did like a 10-second short video. I don't know if any of you saw it. This was a long time ago. It was like 10-second short and showing my steak and bacon and eggs, which is extremely delicious. Highly recommend that. But I just prefer the bacon and egg cheeseburger. All right, let's get this non-PLA. Let's get this non-ASA. Let's get this. Don't cook it at 260 degrees PLA out of here. I'm gonna throw this in the middle of the road. Let's grab this. Oh, you know what? I have black. I have gray. I have this box of gray ASA, a brand new box. Because I did the other parts in black. I did like the frame parts in black, and now this is 2 ducts, and so I guess I'll do ducts in gray. I ordered a cool red. What do they call it? It's a crimson, so it's like darker. It's like blood red kind of. But that's probably not going to be until tomorrow. And so I might still do some red. I don't know, black and gray and red. If you didn't see the unbox video, all the tubings, all the extruded, what do you call it? Extruded aluminum frame members are black anodized aluminum, and then the reinforcement parts I printed for the frame are black. That's not far enough. The LCD for some reason is not seating all the way. There it goes. Alright, so we get some nice gray ASA here. And so I did the frame reinforcement parts, like the feet and stuff, in black also. And so I'm going to do now I'm doing the cooling ducts. Like the K1 has this one cylindrical blower on the side with a duct that comes up. And this is the kit. It's got one on each side, and the blower I think is bigger. The ducts are definitely a lot taller. It's just a bigger build volume machine. Alright, so let's put, this is definitely a little awkward, and you may have noticed if you are a subscriber, if you've seen it before. Hey, and that reminds me, if you've seen some of my videos and you're not subscribed, that would be awesome if you subscribe. Because as I like to say, things like that tickle the underbelly of the algorithm there. And so it's good stuff if you do that, and if you like it, you hit the thumbs up. If you hear this, like, I can't imagine anybody still watching now. If they're like at the nursing home, somebody put it on and they had a stroke and they can't get up to change the channel. I don't know. But if anybody is still watching, it would be cool if you excuse me, if you order me food delivered because I'm starving. No, it'd be cool if you hit the thumbs up, subscribe, and share with your friends. Come on, get in there. Well, I think extrusion will do that. So let's turn it on and see what we got. And nothing happened. I think it came unplugged. It came unplugged. Well, it came half unplugged, which is convenient because all I had to do was shove it in. And that's what I was saying. I don't know what I was saying. Probably too much. Let's put the rubber feet on while it's booting up. It actually boots. Oh, there it goes. It seems to boot up a lot faster now that with the new firmware. Maybe it was my imagination. Yeah, that was pretty quick. It's already booted up. So let's do extrusione. Oops, wrong button. I could get that on video, but I'm pretty sure you know how to do this part. I'm going to go to 260 because let me check the box, make sure it's not in fact PLA. Gray. Polylite ASA. Weather resistant ABS. Already done. Let's get the rubbery feet on. Little tip on the rubbery feet is I threw some of the bed glue because they just fall off so easy. So I threw some of the bed glue because he's kind of schmibbering there. A little bit of bed glue in there helps them not fall helps them to not fall off if you pick it up. You still screw it if you try to slide it. Okay, 260 extrude. So they still fly off if you try to slide it around. So always just pick it up. If you're gonna move this printer, grab it by the corners, pick it up an inch, and move it and drop it. I think I almost tore my bicep in half too because I was doing curls with 12.5-pound dumbbells the other day. You know, hockey preseason and all. Well, it's not preseason, but what do they call the off season when you train in the off season?